Revelator John.
Hello Revelators, welcome to Revelator John. Another video here today about weather theory. So today I'm going to be talking about a temperature inversion. So a temperature inversion is where effectively the temperature in the atmosphere doesn't follow the standard path. So normally what happens is that as we gain altitude, the temperature decreases. And look at my other videos for why that happens. But as the altitude increases, temperature decreases. However, sometimes that is not always the case. Now, there might be varying layers of airflows, for example, that might be bringing warmer or colder air. So what happens is that as we gain altitude, there isn't always this gradual decrease in temperature, and it tends to stutter, or it might even reverse. You might have a colder temperature, then might suddenly go into a warmer temperature, and then back into a colder temperature. So as we gain altitude, we have a certain temperature and it's starting to decrease. So at some point, okay, it encounters warmer air. So that warmer air, okay, that is the inversion layer. So below that inversion layer, okay, we have the greater potential for water vapor condensing out. Above that inversion layer, in the warmer temperatures, there'll be less condensation, if any at all. So as we look at an inversion layer, if there is any condensation beneath the temperature inversion, there'll be a very definite line in the clouds, or atop of the clouds, or in the haze layer, or in the fog layer, or whatever it is. The condensation below will suddenly stop. Let me lower my arm so you can see my lips. So the inversion the condensation will suddenly stop. Above will be clear, below will be continued the condensation. So below the inversion, typical weather is low cloud, poor visibility, fog, haze, that kind of thing. Above the inversion layer, usually better weather. So clearer weather, better visibility, less cloud, so on and so forth. Because of the temperature differential, because of potentially the different airflows between the lower inversion, from below the inversion and above the inversion, there might be some turbulence around that inversion boundary layer as the airflows mix with each other. But essentially, below the inversion, we would normally associate airflows or wind to be relatively light and poor visibility, but it will be a relatively stable atmosphere. In other words, not a lot of vertical development, because the temperature inversion, the higher temperatures above, are minimizing or preventing any condensation above in that temperature zone. So I hope you understood the temperature inversion and the effects of it and the weather associated with it. Thank you.